do that. Oh, that's not too bad. Okay, so yeah, I'm not gonna leave it there too much. Okay, so with this one, so Aubrey, if you're watching this, you're just gonna want to pause so you can write this down. Okay, so sum and difference. So what we're looking at is we have our snowman and we have certain values on there, but what if something's not on my snowman? Can I still find the value here? So what you'll notice on this, and you'll know which one you're supposed to use, but I'm going to give you a value like I think cosine 75 is probably the one we're going to do. And it's just find two numbers that add or subtract to give me 75 that are on the snowman. And then we'll just kind of go from there. I didn't mess up the signs on cosine. You'll notice when I'm adding two angles over in the identity, it's subtract. And when I'm subtracting two angles over there, I'm adding. Tan is the same way. Yes, it's adding up top, but then on the bottom it says minus, but then you go down to the subtraction ones. Tan, it's minus up top and plus on the bottom. So those aren't typos. That's just kind of how it is. Okay, so unit circle, you have that. Okay, so we're going to look at cosine 75. That's the example I'm going to do here. Okay, so what you're going to do is look on your snowman, snow person. Find me two numbers that add or subtract and give me 75. 30 and 45. You don't have to use 30 and 45. You can kind of use whatever, but you're picking two off of there. They're not just two random numbers that give me 75. It's two that are on here. So if you say 45 and 30, then I'm going to rewrite this as cosine of 45 plus 30. Oops. Now let's see if I can see that on there. Yeah, it looks okay. All right. So now all I'm doing is just kind of filling in on that identity. So it'd be cos 45 and then minus okay, so I'm rewriting 75 with two numbers I definitely know, 45 and 30. All right, so now look at your snowman. What is cosine of 45? And then what's cosine of 30? Cosine.
Oh, square root 3.
Square root 3 over 2 minus, and then sine 45. Square root 2 over 2, right? You're just looking at 45. And then you want sine of 30. What's sine of 30? Yep. Okay, so once you rewrite the 75 or whatever number I give you there, I know I'm using cosine. And so like I said, it's just finding two numbers that add or subtract to give me that. Okay, so now when I multiply these, the square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is just 4. Square root of 2 times 1 is just square root of 2. 2 times 2 is 4. They have a common denominator, so I can write them as one fraction. I boxed it up. I'm done. Remember, I can't take the square root of 6 minus the square root of 2 and get the square root of 4 and call it 2. Okay? Remember, it's not 6. It's the square root of 6. So I would have 2 point something minus 1 point something. All right, so just leave it just like that. So they'll kind of look like this. for 75, you didn't have to use these two. You could have done something like 135 minus 60. Okay, so if you do 135 minus 60, you'll get 75. And so in here, you would have cos 130, you'd have cos 60, and then a plus. And so it doesn't matter what two. I just said find two that either add or subtract. So cosine tells you out of the three identities, you know, sine, cosine, tangent, which one you're going to use. And then it's up to you to come up with what adds or subtracts to give me that. Is usually in pre-calc, I say, okay, cosine 75, don't give me 45 and 30. So it forced them to look for something else. But at the end of the day, we ended up with the same answer. It'll be okay if you end up with a minus square root 2 plus square root 6. You know, if these things are out of order a little bit, that's fine. It'll be the same thing as long as the signs in front of what we're talking about is the same. So on all of these, it's just finding something that adds or subtracts to give me that. But they're all values on your snowman, so you can fill in these when you're done. Okay, so if it gives you a specific number just like that, that's what you're looking for. And it could be add or subtract, like I said. All right, so the next one, actually what I want you, the top line just tells you you're in the first quadrant. If you're from 0 to pi over 2, you're in the first quadrant. So this one, I'm not using my snowman, but I'm going to make some triangles. I would like to do a tan one. We don't have to do all three of those. Let's do the tan. For problems like this, you just really need to watch what quadrant they're putting you in. I'm just putting you in the first. But let's just do this one. Let's do this bottom one. That's 3 different examples. Let's just do the one with tan. Tan is a big fraction one. So they'll tell you what quadrant to put your triangles in. Okay, so we're doing tan. And then it says sine of x is 4/5 secant y is 17/8. Okay, you guys got that down?
No, not yet. I didn't know you're writing that.
Oh, just the last one. Don't write down the sine and the cosine because you kind of saw them the same way here.
Okay.
Oh my gosh. Okay. All right. I'll get out of here because I wrote it on here. Okay, so the first one gave you an actual kind of degree, 75 degrees. Find me 2 numbers. So on this one, when they don't give you degrees, what they want you to do is draw 2 triangles. So one of my triangles is going to have an X, the other one's going to have a Y. So since they're in the first quadrant, I'm just going to draw them like this. I'm not drawing anything to scale. I'm just drawing them. Okay. So, but like I said, I put them in the first quadrant, but they could put them anywhere. So I just kind of draw them where they would be. So I know if I go back, it's negative. If I go down, it's a negative. That's okay. Okay, so sine of x is 4/5. Where am I going to put the 4? Where am I going to put the 5? Where am I going to put the 4? Where am I going to put the 5?
4 opposite 5.
Okay. So this right here is going to tell you how to draw that triangle, where to put some numbers. So what's this other number that's here? If you have, so 25 minus 16 gives you 9. The square root of that is 3. Okay. All right. What if this one over here told you secant was 17 over 8? Where's the 17 and the 8 go? So hypotenuse and the adjacent. And then if you do a squared plus b squared equals c squared, I believe you should get a 15. We're just going to double check it real quick because, yep, 225. Okay. So now I am going to not pull in stuff off my snowman. I'm going to pull off of here. So tan. I'm just going to write it here. You have it above you. I don't. One minus 10x tan y. Okay, so you have that written above on yours. I just don't have it on mine. Okay, so now all I'm going to do is go back to these triangles and pull off the values. So before we pulled them off the snowman when I gave you degrees, but this one I didn't. So what's tan of x?
4 over 3.
Tan of x is 4 over 3, right? Yes, Kylie? Yeah. Tan of y?
15 over 8.
Okay, and then for the bottom, I'm using those same fractions because this one just has to do with tan stuff. So the first part of it will tell you what equation or identity you're looking for. So it was the tan x plus y. The next part of it told you how to draw your triangles. You got to do a little a squared plus b squared equals c squared. And then it's just plugging in those fractions in here. Okay, so let's go do this bottom part. 3 and 8, what's my common denominator? 24. So if I take this times 8, I take that times 8. If I take this times 3, I take that times 3. Are we good there? And this is just my equal sign right here. It's not negative. Okay, so common denominator 24. So the one on the left times 8, the one on the right times 3. So far, so good? Okay, so now what's 32 plus 45?
77.
So up top, I got 77 over 24. So we got that whole top part condensed down to one fraction. Okay, now the bottom one, what I'm going to tell you to do is just multiply these two things. So when you multiply those two things, what do you get? No, just straight across.
Okay.
60 over 24. Okay, now go back to that 1. What am I going to change that 1 into?
4 over 2.
Ones are the easiest number to put into a fraction because you just look at the denominator you have, write it twice. Okay, so usually when I do the top part, that's done common denominator. On the bottom, for tan like this, I would multiply, and don't worry about simplifying anything. We can simplify it later. Just multiply it, dump it, and then change that 1 into whatever this is. So now you have 24 minus 60, which gives you what? Negative 36, and then over 24. So, but just doing common denominator up, and then add them up or subtract them, whichever one you have to do. And then on the bottom, multiply, and then change your 1. Okay, how do you divide fractions? Hey, There's your first one, there's a dot, and there is your second one. I would right here just cross out those 24s. And then you have your negative 77 over 36. You're going to get some weird fractions in there, but that's okay.
And that's the answer?
Yeah, if you can simplify that very last, simplify it. But the only thing that's going to go into 77 are going to be 7 and 11, and 7 and 11 are not going to go in 36. So, yeah, and I know back here, I can simplify in here. Obviously, 4 goes into 8 and 3 goes into 15. You can simplify back there if you want. I just did it, and that was it. And then my 24s canceled out. Heck, my 24s just cancel out right there and leave it as 77 over 36. But so this up here will tell you which one you're using. Whoa, which one you're using. The next information tells you how to draw these two separate triangles. One is X, one's Y. One's A, one's B. It doesn't matter what they use. One's alpha, one's beta. Who knows? But that tell you how to do it, and then you can find that third number doing a little a squared plus b squared equals c squared. And then it's just a matter of plugging in fractions here and then just kind of simplifying. Okay, now I left it over here. Let's see, last example we're going to look at is, we're going to do this one. So you're just going to kind of verify that this is true. Okay, so this is my more complicated side, and so I'm just trying to get this side to look like this. Okay, so if you go back to sign difference, it's one of the first things you wrote down. I can kind of expand this out. Sign. Because I'm just going back to that very first thing you wrote down. Sine cos minus cos. Okay, so since you were subtracting 2, I just expanded it out. And like I said, it's the second thing you wrote down. So if you do sine of the first, cosine of the second, minus cosine of the first, sine of the second, this is what it is. Okay, now look at your snowman. What is cosine pi over 2? Cosine pi over 2 is 0, so 0 times this gives you 0. What is sine pi over 2? 1 times this just gives you this, so you have, uh-oh. Hey, whoa. Okay, so this is where I was getting to. So first thing we did here was just expand it out, and then we took those values right off the snowman to just kind of plug in there. So this was 0, so that made that all go away to 0. This was a 1, so you just kind of left that as is. Okay, those are the examples I'm doing for that section, and then I'm done.